Hey everyone, thank you for joining this session. My name is Manju Ramanathpura. I am a principal program manager at Microsoft. I am responsible for managing several Azure services, including Azure Cache for Redis. I love helping developers through their digital transformation journey, and I'm thrilled to be representing Microsoft Azure. I'm also quite passionate about open source, so it's great to be at RedisConf. With me, I have Jon Cole joining this session. Jon is a principal software engineering manager at Microsoft. Jon has been with us for over 18 years, working on several developer-focused products. And at the moment, he's responsible for Azure Cache for Redis. Most of Jon's career has been focused on empowering developers around the world to build great software. So in this session, you will get to learn about why Azure Cache for Redis is awesome and is built for enterprise workloads. When I think of enterprises, few things come to my mind: scale, performance, availability, and security. So we will review specific strengths of Azure Cache for Redis that lends themselves well for building scalable, performant, highly available, and secure enterprise applications. We'll also have a fun demo that brings many of these enterprise functionalities together to show you the power of Azure Cache for Redis. So let me first touch on the scale. There are two specific things that I'd like to highlight when it comes to scalability. One, we all know that latency is super critical in the world of Redis Cache. Azure's massive global footprint allows you to quickly deploy and scale Redis Cache closest to where your customers are. Azure's presence over 60 plus regions across the globe and more than 160 additional edge sites also helps you to deploy the application wherever you need them. Azure's extensive support for Linux and Windows platforms and our ever-growing partner offers also allows you to build applications that are right for your business needs. Azure Cache for Redis provides you an easy way of scaling in and out. So that's the second aspect of scaling that I want to emphasize on. You can scale in and out, you can scale up and down. What this means is you can change your cache footprint very easily to align with your application loads. Now let me touch on a little bit about the performance. So from a performance standpoint, there are a few things that I want to highlight. Number one, Azure's breadth in terms of Azure Cache's breadth in terms of memory footprint. It starts as slow as 250 MB and scales all the way up to 13 terabytes. What this means is, again, depending on your application performance needs, you are able to pick and choose the right cache size. Azure Cache for Redis also supports clustering. With clustering, you're able to group multiple caches together to get additional scale and performance. So we talk about how Azure Cache for Redis can make your application faster. But you may ask, by how much? So we asked an independent third-party company, GigaOM, to benchmark the performance gains from Azure Cache for Redis. They built two versions of sample web applications for a basic shopping cart functionality. One used just Azure SQL to store inventory, pricing, and session type of data, and the other one used Azure Cache in front of SQL. Then they compared how the two applications performed. Adding Azure Cache for Redis produced over a 9x increase in the max throughput and 11x improvement in the latency. So this makes a very strong case for you if you are concerned about latency, if you are concerned about throughput, consider putting Azure Cache in front of your persistent storage. Now let me touch on security. There are really two topics that I want to cover from a security point of view today. One is private link, the other one is encryption. Private link essentially allows you to establish secure connectivity between the two network groups. In this specific example, imagine that your client application is in a different network group than where you are running your Azure Cache. This is a normal scenario, and imagine you are also using Azure SQL Server behind the Redis cache for data persistence. With private link support, you are able to actually create a secure tunnel from your application to Redis cache. Once you establish that secure private link, your application can talk to Redis cache. Now, while your application can talk to the Redis cache, it cannot directly talk to SQL Server, even though Redis cache and SQL Server are in the same network group. So this is one of the advantages of private link. From an encryption point of view, there are a couple of things that I want to talk about today. One is encryption at rest, and the second one is encryption in transit. With the Redis persistence, one of the things that Redis persistence delivers is it writes the data into Azure storage. It writes into an account that you own and manage. Okay, so Azure storage automatically then encrypts the data when it is persisted. So you can either use default Microsoft managed keys for encryption, or you can manage the encryption with your own keys. Data in Azure storage is encrypted and decrypted transparently from your application point of view using AES encryption. So in addition to encryption at rest, we also support encryption in transit. Azure Cache for Redis enables SSL and uses TLS 1.2 by default. This allows you to securely transfer data from your app to your Redis cache. Finally, let me talk to you about some of the cool capabilities of Azure Cache for Redis that allows you to build highly available and reliable application. There are two topics I want to cover today. One is zone redundancy, the other one is active geo replication. With zone redundancy support, you are able to build HA within the zone and HA across the zones. HA within the zone is basically by maintaining a replica node of your primary node within the same zone. But across the zone means basically by maintaining a replica zone in the second replica node in a second zone. Now, if the HA within the region is not sufficient for you, or you have a need for supporting roaming user session, we also support active geo replication. By enabling active geo replication, you are able to deliver conflict-free, seamless experience for your roaming use cases, and more importantly, in an unlikely event of region-wide availability incident, you are able to quickly redirect the traffic to a region which is actually functional. And that allows you to maintain the business continuity. So with that said, let me request my colleague Jon Cole to tell you a little bit about fun demo that we have for you. This demo brings many of the enterprise features that I just discussed about to help solve a real-world, geographically distributed enterprise problem.
Thank you, Manju. For this demo, I would like you to imagine that our business unit has been tasked with building a ride-sharing application. Our team, specifically, has been asked to build the back-end REST API service for connecting riders to drivers. The key requirements are that it be deployed to multiple regions, be scalable so that it can grow as load increases over time, and it must be resilient to both partial and complete regional application failures. As a side work item, we decided we also wanted to build a simple web dashboard to show usage of our service along with some driver information. On the right side of the slide, you can see an example of the dashboard we have built so far. At the top, you can see a graph of the API calls that are currently being made to our backend service. The graph shows the global total number of API calls in blue, as well as calls to individual regional endpoints in red and green. This service is currently deployed to 2 regions. In the middle of the page, you can see maps showing driver locations for Seattle and New York. And at the bottom, you can find a list of active drivers. The architecture diagram to the right shows the key pieces of our REST API. Each of the boxes at the bottom left and bottom right represent a regional deployment. As load increases, we will be able to easily scale individual resources within the region or deploy to additional regions if needed. Within each region, we've deployed our application components to 3 availability zones. This helps us maximize resilience within the region in case of a partial application failure should it occur in the regional deployment. To host our API, we've chosen to use Azure App Service, which is capable of hosting most of the key web application frameworks and programming languages you love, such as Java, .NET, Ruby, Node.js, PHP, and Python. These applications can be hosted on either Windows or Linux, and of course, Docker containers are supported. For persistent driver data, such as driver IDs, names, addresses, etc., we have decided to use Cosmos DB, which is a NoSQL persistent data store that supports multi-region geo-replication with all regions being writable. For more transient data, such as current driver availability and location, we are using Azure Cache for Redis, using the new enterprise tier, and have chosen to use geo-replication to give us cross-region replication and immediate failover capability. This configuration also allows writes in all regions. Redis is also doing our geospatial calculations for determining driver to writer matching. For our REST API, we have decided to use Azure Traffic Manager, which is a DNS-based connection routing system. This connection routing can be based on priority, a weighted value, performance, or geographic location. Traffic Manager also gives us some useful analytics, such as the geographies from which traffic is originating. Traffic Manager also has endpoint monitoring for automatic failover. Our current monitoring configuration performs a health probe against each regional endpoint on a 10-second interval. And it is set to tolerate 1 failure before making the endpoint as unhealthy. At which point, the unhealthy endpoint is no longer returned in DNS query results. Our web UI dashboard is also being hosted in Azure App Service and is scaled out to multiple regions as well. Instead of using Traffic Manager here, we decided to use Azure Front Door as it has more HTTP specific routing options such as protocol, hostname, HTTP path, session affinity, or latency. It also supports back-end health monitoring, as well as private endpoint connectivity so that we can easily restrict access to this internal dashboard. Now I would like to demonstrate what a failover in the real world would look like. Okay, here what we have is the live version of our dashboard that we have built. Again, you can see at the top the graph of the calls into our backend REST API. And this is the piece that we want to focus on for this part of the demo. What we have here is you can see that the load that's being generated on this application is fairly constant. You can see that the load is kind of split between EastUS2 and our EastUS2 API endpoint and our WestUS2 API endpoint. What we're going to do to simulate a failover is we're going to turn off the API in our EastUS2 region. We're just going to stop the web application. And that's going to mean that the application that is generating this load is going to start to see failures. And we're going to observe what happens. Here I am inside of the Azure portal, just telling the web application to completely stop. Now what we will see here momentarily is that traffic will dip briefly because the application will see a few failures. This is because we have set up the traffic manager, as you recall, to allow about 10 seconds of failures before it reacts. You can see a very slight dip, but then you can see that very quickly traffic is diverted over to the West US endpoint while all traffic stops on the East US 2 endpoint. Traffic Manager detected it quite quickly and was able to react. Our application, our client application on this REST API is configured such that when it sees failures, it immediately refreshes the DNS and tries to reconnect back, knowing that Traffic Manager will direct it to the right endpoint or other endpoints that are still available. Let's go ahead and turn this endpoint back on and see how recovery looks under this condition. Now it will take a little bit of time because Traffic Manager is choosing to be a little bit careful. It wants to be cautious to make sure that it doesn't proactively send traffic back to the previously faulty endpoint too aggressively. So here momentarily we will see that an uptick in our East US 2 traffic, as you can already see that it's starting to recover, and you'll also see a corresponding downtick in the West US 2 traffic because the traffic is now being redirected back to the endpoint that has become healthy. All of this was done automatically. We did not have to push any buttons in our client application. It was able to detect this and react appropriately without much without any intervening on our part. As you can see, this was a very smooth experience. The overall load was continually pretty good. There was a slight dip, but the system was really quite stable and responded very quickly. This concludes our demo. To briefly recap, our small team was able to very quickly build this application by leveraging several Azure building blocks, including Redis Enterprise. The team was able to develop a highly available backend service that is easy to scale and allows clients to be resilient to unexpected service failures. Thank you for attending our talk today, and we hope that it has been helpful. We also hope you enjoy the remainder of RedisConf.